Right, let's start to solve the next set of problem of our discussion session. So this is problem 511 of white textbook. Here we're going to talk about it. First, I'll write down about the statement of the problem. It states during World War II, Sir Geoffrey Taylor, a British fluid dynamist, used dimensional analysis to estimate the wave speed of an atom bomb. Explosion. He assumed that the blast wave radius r was a function of energy released E. Air density rho and time t. Use dimensional reasoning to show how wave radius must vary with time. Now to solve this problem, the solution involves solving it by the Pi theorem. So as per the statement of the problem, we can understand the proposed function is wave radius r is dependent on a function of energy E, air density rho, and time t. So let's try to solve this using Pi theorem. Step 1 of the Pi theorem As per the step 1 of Pi theorem, we need to list and count the n variables involved in the problem. If any important variables are missing, dimensional analysis will fail. The first and foremost step is to write down the number of variables that are present in this particular problem. So, number of variables from the function, the proposed function that we have, the variables that we know as per the problem involve wave radius r, energy E, air density rho, and time t. From this we can conclude, hence we have n variables equaling to 4, as there are 4 variables involved in this problem. Let's move on to the next step, step 2. What does step 2 state? Step 2 states, list the dimensions of each variable according to m, l, t, or theta. And so step 2 asks us to define the dimensions of each variables. So the dimensions of variables, let's say we have r, then we have E, we have rho, and we have t. Let's treat that in that manner. So r is radius. So radius is measured in terms of length. So the dimension of r would be L. and E is energy. The you can find the dimension of energy from table 5.1 of your textbook, which is on page 296, and the dimension of energy or work is given by m l square t power minus 2. Rho is density, which is mass upon volume, that would be m l power minus 3, and t is time, it's a basic dimension, so that is given by t. Now let's try to invoke next step, which is step 3. Step 3 of the problem says find j, initial guess j equal to the number of different dimensions present, and look for j variables that do not form a pi product. If no luck, reduce j by 1 and look again. With the practice, you will find j rapidly. So in this step 3, we are told to calculate the number of dimensions. So the number of dimensions involved in this particular problem. So what are the number of dimensions that are involved in this problem? That are, if you observe the step 2, you'll observe there are 3 particular basic dimensions that are being shown, which are m, l and t. Let's write them down. Do you see anything else other than m, l, t? Is there any other sort of dimension like theta? No. So m, l, t. So therefore j is equals to 3. Step 4. Select j scaling parameters that do not form pi product. Make sure they please you and have some generality if possible, because they will then appear. So step 4 says select the parameters of j parameters. So select E, rho and t. Because these are the parameters or the function or these are the parameters that R uses to form its uh, dimensional value. So R is dependent on these 3. I would say these 3 are the selected parameters, or let's say j is equals to 3 parameters. Step 5. Add one additional variable to your j repeating variables and form a power product. Algebraically find the exponents that make the product dimensionless. Try to arrange for your output or dependent variables, force, pressure, drop, torque, power, etc., to appear in the numerator, and your plots will look better. So basically we are trying to deal with step 5 is to find the difference or calculate the value of k which was described in the Pi theorem, k should be less than or equals to the difference between n minus j. So number of pi groups is equals to n minus j, and that is equals to 4, or the number of variables n, and j is 3 parameters. So when you subtract them, you will have one particular pi group coming out. So the first dimensionless group which is pi 1 is nothing but E rho t plus the actual one r. So this can be represented as pi 1 is equals to, let's give a power of them and equate them, e raised to the power of a, rho to the power of b, e to the power of, t raised to the power of c, and these are dependent on r. So r is an independent variable. We do not give any power to it. Let's say r is power to the 1. But we do know that pi 1, which is the first group of pi group, is dimensionless. So that implies we can build up an equation or relation as e raised to the a, rho raised to the b, t raised to c, r is equals to, if pi 1 has to be dimensionless, so your pi 1, in place of pi 1, it has to be a constant, which can be written as m0, l0, t0. Now let's substitute the values of e, rho, t and r, which were represented as dimensions, and build it up. So the first part, e, is m l power minus l power 2 t power minus 2 whole raised to a. Rho is m l power minus 3 whole raised to power of b, and t is t raised to the power of c, whereas r is radius, which is length. This is equals to our right hand side, which is a dimensionless product, which is m raised to 0, l raised to 0, t raised to 0. So the previously written dimensionless group to be shown, I have represented. Energy is m l square t power minus 2, and it was to the power of a, so I put the power of a. Rho is mass upon volume, so that is represented as ml to the power of minus 3 raised to the power of b whole raised to the power of b. T is time, which is represented by in dimension form as t, capital T, raised to the power of c, and radius r is a measurement of length, which is represented as l, and r has a power of 1, so I'm not representing any power to that. Without any power, it means it is power raised to the power of 1. On the right hand side, we stated pi1 as dimensionless, so hence we have written also right hand side as m in terms of mlt, but to bring it as dimensionless as a constant, we have risen the power of each dimensional basic dimensional value to 0. Now if we have to write the basis and we can equate the powers, or let's build up the basis and raise the powers to that. So the first one will be m raised to the power of a plus b. L, you have power raised to 2 into a, which is 2a, minus 3 into b, which is minus 3b, and there is only power raised to the power of 1. Let's add that, plus 1. Next we have t raised to the power of minus 2 into a, which is minus 2a, and there is no other point just except for c, which will be plus c, is equals to m0 L0 T0. Now we have this right hand side and left hand side, left hand side and right hand side with in terms of MLT. So by comparing powers, by equating bases, we can calculate the values of a, b and c, which implies first one is a plus b, which is for m, is equals to 0, 2a minus 3b plus 1 is equals to 0, minus 2a plus c is equals to 0. From this we can imply a is equals to minus b minus 2b, which means if we substitute this in place of the second equation, we can write it as minus 2b minus 3b plus 1 is equals to 0, which implies b is equals to 1 by 5, and if we substitute this back into the previous equation, we get a is equals to minus 1 by 5. And using a and b, if we can try to solve the third equation, we get c is equals to 2a, which implies c is equals to 2 multiplied by minus 1 by 5, which will be minus 2 by 5. Substituting a, b and c values in pi1 group, we can write it as pi1 is equals to e raised to power of a, which is minus 1 by 5 rho to the power of b, which is 1 by 5, and t to the power of c, which is minus 2 by 5, and finally r raised to the power of 1. Let's leave it like that. So once you look at this, you can rewrite this equation as pi 1 is equals to r rho raised to the power of 1 by 5 whole divided by e raised to power of 1 by 5 t raised to the power of 2 by 5, which is equals to this particular arrangement of pi group, since it is dimensionless, is equals to a constant. Then we can thus say, due to the constant arrangement, the r, which is radius of the wave, is directly proportional to the time as to the power of 2 by 5. And that concludes our statement. I hope everything is clear and understandable, but if you do have any questions related to the problem, you're free to ask. You can send me an email, or you can also chat with me or call me over Microsoft Teams during the session time, or even during my office hours. Thank you.